Yeah, there is a linked answer question. Consider the following Gantt chart representation illustrating the execution of process P1, P2, P3, P4 and P5, all of which are assumed to be arrived at time 0. Using FCFS and SJF scheduling policies, all the times are given in milliseconds. So here one table is given, that is the execution sequence, that is algorithm used, and waiting time is mentioned for each process. FCFS, the process order is 1, 2, 3, 4, 5, and already it is mentioned that all the processes are arrived at time 0 in the order of 1, 2, 3, 4, 5, and P1 waiting time is 0 using FCFS, P2 waiting time is 10, P3 11, P4 13, P5 14. Usually when burst time are given, we used to find out the waiting times, but here the waiting time is given, he is asking the burst time of process P5. And SJF process order execution is 2, 4, 3, 5, 1, and P1's waiting time is 9, 0, 2, 1, 4 respectively for the SJF, shortest job first. The question number 1 on this data is, what is the burst time of P5? We need to find out the burst time. Burst time is the amount of time that P5 will take on CPU. So here first let us execute the Gantt chart representation using FCFS and SJF so that you can find out the burst time of process P5. In a Gantt chart, for example, if you take FCFS, P1 waiting time 0 means first you have taken P1, and P2 waiting time 10 means because P2 came after P1, so at the 10th second P2 will be over, P1 will be over, the waiting time of P2 becomes 10. Waiting time of P3 is 11 means at 11th second P2 is finished and P3 is waited up to that and P3 is taken. Again P4 is 13, that means P3's burst time is 2, 13 minus 11. P2's burst time is 11 minus 10, that is 1. P1's burst time is 10 minus 0. Similarly, P4 waiting time 13, no? So that we will write P4 in the Gantt chart here. Again, P5 is the 14. That means here we will take P5 for execution. But when P5 is ended, we can't know using this strategy now, because only waiting time of P5 is given, and that is a process that is executed at the end. So that let us see the SJF also, so that we will get that burst time of P5. What is the order of execution? We have to take the shortest job first. So now SJF first 2 is executed, that is 0 is the waiting time, that is already given here. Process P2 waiting time is 0. So P2 again next at first second, next fourth process waiting time of P4 is 1, and again third process P3 came at second, again one more process after P3 is P5. So P5 came at 4th second. So now again the last process is P1, it is came at 9th second. Already we know that P1's execution time is 10 seconds, so that 9 plus 10 at 19 P1 will be finished. And here we got a slot of 4 to 9 for a process P5. Earlier in FCFS we did not find, because the ending time of P5 is not known. As P5 came in middle, we got the execution time of P5. So 4 to 9, that is 9 minus 4, 5 milliseconds is the burst time of process P5. And the burst time of all other processes are also coincided when you use FCFS and SJF respectively. So P1's waiting time here 0, here also it will be 9 actually, but burst time will be 10 here, here also 10. Burst time was coincided. Waiting times are different for different process using the different strategies like FCFS and SJF, that both are listed here. So P5 burst time is 5. Option D is the right option here. So there is another question which is linked to the previous question we discussed. What is the average waiting time if algorithm used is round robin with a time quantum of 1 millisecond and the process order is 1, 2, 3, 4, 5? Option A 4.2 milliseconds, B 5.4 milliseconds, C 6.3 milliseconds, D 3.9 milliseconds. So here we have to follow the round robin technique. In a round robin technique, usually every process will be executed in a particular time span. After that the CPU will switch over to the next process. We will set a timer. For example, if time quantum is equal to 1, after every 1 millisecond timer will be reaching to 0, so that interrupt will be occurred, the context switch will occur, the next process in the ready queue will be taken. So the first process is 1, next is 2, 3, 4. The order is given. Anyway, Even if the order is not given, the round robin technique will be following FCFS order. So here we will take the Gantt chart representation. We need to find out the average waiting time when this algorithm is used. Already we know that the execution times already we know. That is the execution time of P1, execution time of P2, P3, P4 and P5. The P5's execution time is, we found in the previous problem, that is 5 milliseconds. P5 execution time is 5 milliseconds. And P1's execution time is 10. P2's execution time is 1. P3's execution time is 2. P4 execution time is 1. That's what we already found based on the Gantt chart that is represented by using the FCFS and SJF. So here we are going to find out the waiting time, average waiting time using the round robin technique. The process order will be, first P1 will be executed 1 second, next P2 1 second, P3 1 second, that is 1 millisecond, P4 1 millisecond, P5 1 millisecond, again it comes back to P1. If there is any remaining term, that will be finished, it will go to the next process in that order. So now it will execute P1. After 1 millisecond is over, by that time 1 millisecond of P1 is over, remaining is 9. And that P2 will be executed 1 millisecond up to 2, and P3 will be executed up to 3, P4 will be executed up to 4, because every process slot is 1 millisecond. P5 is 5, at 5th it is finished. P1 again it will be taken. Okay, it will be taken up to 6. Again P3 up to 7, P5, because P4 is already finished within a single slot, because it requires only 1 millisecond of time. P5 is up to 8 and P1 is up to 9. Again P5 is up to 10. Again P1 is up to 11. Again P5 is up to 12. Again P1, only P1, P5 remaining, all other are finished. After P5 we will take P1 again, it will execute up to 13. Again P5 is up to 14. At 14 second P5 is finished. Again we take all P1 slots only. For finding the waiting time, we need not finish the total P1, because there is no other process in the queue, only P1 is there. It will take multiple slots for the execution. Whenever P1's execution time is over, it will finish the system. So now the waiting time of P1, initially it is 0, later on it will become 5 minus 1, that is 4, next is 2, 1 plus 1 plus 1, this is 9. P2's waiting time is only 1. P3's waiting time is 2 plus 3, it is 5. P4's waiting time is 3 seconds, because it is finished in one slot. Of course P2 is also same. And P5 is 4 plus 2 plus 1 plus 1 plus 1, it will be 9 total. So the average waiting time is the sum of the waiting time of all the process divided by the number of process. So this total sum will be 9 plus 1 plus 5 plus 3 plus 9 divided by number of process, or 5. It will be 27 by 5, 5.4 milliseconds. So option B is the right option here.